Go ahead. I'm sorry, what?
X squared plus 5x minus 36 over 4x minus 1.
Okay. These are always factoring problems. Whenever you see a quadratic, that means it's a factoring problem. Okay, we got a quadratic here, 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 and there. We got 4 quadratics that we need to factor. Now, we could tackle factoring them all by ourselves, but they're giving us a clue with these 2 linear factors here. That almost certainly is the factor of one of these quadratics, and this almost certainly is the factor of one of those quadratics. So let's start on the upper left. Let's factor this one right here. Let's do it, let's just factor that. Should we try 2x and 2x, or should we try 4x and x?
Probably 2x and 2x.
Normally I would agree. In most factoring problems, your solution is going to be the factors that are closest together. 2 and 2 are closer together than 4 and 1 are. But given this 4x minus 1 over there,
oh yeah, okay.
I'm guessing that 4x minus 1 is one of the factors. So I'm going to try that. Okay? What are my signs?
Negative and positive.
Actually, they both have to be the same because of that positive. You can't get a positive 3 unless I'm multiplying 2 negatives together or 2 positives together. So this tells us that they both have to be the same, and this tells us they both have to be negative.
Okay.
Okay? Well, there's only factors of 3, or 1 and 3. Let's try the 1 there and the 3 there. Does that produce a middle term of minus 13?
No.
Actually, it does. Here, let me show you how I do this. This is an important part of factoring here. First of all, I don't need to check this term here because I did this factoring based on splitting up 4x squared into 4x times x. So I know that that term is correct. I also don't need to check this term because I, again, based my factoring on the fact that these two numbers had to multiply to 3. The term that I'm in doubt of, and you're always in doubt, is the middle term. So how do you get the middle term? You get the middle term by multiplying the insides together and the outsides together. Kind of what I call my smiley face method. Okay? Well, when I multiply the inside together, I get minus 1x. When I multiply the outside together, I get minus 12x. Add those two together, minus 13x. That indeed is my middle term, so I have factored it properly. And that's the process I always go through. In other words, I break up the first term, determine my two signs, factors of 3, and then I make sure that I'm producing the middle term properly by multiplying the insides and the outsides, the O and the I of FOIL. Okay, so I can split this into these two things. So I'm going to go back up here and erase that and replace it with 4x minus 1 times x minus 3. And we can already see that this 4x minus 1 is going to cancel out with that 4x minus 1 over there. So now let's work on factoring the bottom, the denominator. Well, let's do the same process. Only this time we know that it's 5x and x. No other choices. What are the signs here?
I think one is, they're both negative?
No, they have to be opposite. We cannot get a minus 10 unless they're opposite signs. Notice that this third term of this quadratic is always produced by multiplying whatever is there times whatever is there, including their signs. So I know my signs have to be opposite. It has to either be plus minus or minus plus. And in this case, they're not the same. With a lot of factoring, if you have x and x, then plus minus is the same as minus plus, and you can get away with just writing plus minus. But when the coefficient of this term is different, actually when any of these coefficients are not 1, then you have to allow for both plus minus and minus plus. Okay, so now we're looking for factors of 10. What are factors of 10? 10 and 1?
1 and 10, 2 and 5.
And that's it. Okay, again, looking at one of these linear factors up here, 5x minus 2 is a clue. I'm guessing that it's 5x minus 2 there and x plus 5 there. Okay? And there's nothing wrong with using these clues. If I had to factor this without that clue, I would eventually get to this. Let's just check it to make sure that it produces the proper middle term. Well, that gives me a minus 2x. This gives me a 25x. Add them together, you got 23x. So it's factored properly. Okay. Without that clue, I would have had to maybe do a little trial and error. Factoring is a lot of trial and error. No matter what method you've been taught how to do it, I don't know if they taught you the California method, the diamond method, the table method, there's a little bit of trial and error involved in it. And with my method, I don't use any of those methods. I use exactly the method that I just showed you, where I'm going to try factors of 10 until I find that I produce the correct middle term. And I would just try them at random. I would try all 4, starting with 2 and 5, because they're closer together than 10 and 1 are. Okay, so now I'm going to go back up to our equation and replace this denominator with those 2 factors. 5x minus 2 and x plus 5. And I can see that the 5x plus 2 is going to cancel out with this 5x plus 2. So I'm whittling it down. And now I've got to factor this expression and this expression. And I have one clue, this x minus 3, but these are actually very easy to factor. Whenever your quadratic starts with x squared, it's really a piece of cake factoring. There's no longer any trial and error needed. Start by splitting up the x's, or the x squared. What are my signs?
One's going to be positive and one's going to be negative.
And that is going to be the same as if I put a negative here and a positive there. In other words, I don't need to do this on this one. Okay? Because my coefficient is 1 in front of the x's. Now I can say I'm looking for factors of 36 that subtract, because of that negative sign, to the number 5. Well, let's list our factors of 36. I don't know if they've taught you how to do this, but the way I usually find factors of a number is I start out with this, and then I cut this in half and double this. cut that in half again, double this again. I can't cut this in half anymore or double this, but I could cut this in a third and triple this. So that's one way to get your factors, is to just gradually break it down. Well, there's lots of ways to do it, but this is a convenient way. So which of those factors subtract to the number 5?
9 minus 4.
Okay. Put the larger of those factors, the 9, with the sign of the middle term. Well, the sign of the middle term is plus, so the 9 goes right there. 4 goes right there. Again, I want to check. Make sure that I get a plus 5x in the middle. I don't need to check the minus 36. I don't need to check the x squared. Well, that's plus 9x. That's minus 4x. Gives us 5x, correct middle term. We factored it properly. We can replace that right-hand numerator with these two factors. X plus 9 and x minus 4. Now, when I have a line drawn through something, because I canceled it out, it didn't leave 0, it left a 1. In other words, this becomes a 1 along with this 1. So I don't write it because it's a 1. Okay? So the only thing left to factor is this quadratic here. And again, this is a very easy one to factor because it's x squared. In other words, there's no coefficient in front of this x squared, which means you can narrow it down. There's no trial and error required. What are the signs?
Plus and minus.
And what's the rule I want to use now?
What do you mean?
I want factors of 27 that do what?
Oh, that add up to 6. Or subtract.
Subtract to 6. If this was a plus, then they would need to add to 6. But you key off of this sign. This sign right there is really powerful. It tells you what both your signs are, and it tells you what the rule you need is. So I need factors of 27 that subtract to 6. Well, that's pretty easy. 9 and 3. Where's the 9 go?
On the left?
Yeah, it goes with the sign of the middle term. The 3 goes there. Once again, that gives me plus 9x minus 3x plus 6x. I always do that last check. It's only the middle term that's difficult. So now I'm going to replace this with those two factors, x plus 9 and x minus 3. And now, if I erase all of this and look at what we have, we've canceled most everything. Can I cancel anything else? Yes, I can cancel that x minus 3 with that x minus 3. What are we left with in the numerator? This x plus 9 times x minus 4. And in the denominator, I can cancel that x plus 9 with that x plus 9. Now we're only left with x minus 4 in the numerator. And what are we left with in the denominator? This x plus 5. There's your answer.
All right.
Okay? Now, in all of these problems, the only time you can cancel stuff is if they're exactly the same. Almost. I'm going to give you one exception to that. But if I have an x minus 2 over an x minus 3, I can't do anything with that. That's the simplified final form. There is one exception, and that is if you have like x minus 3 over 3 minus x. That is equal to negative 1 always. And by that,
Okay.
I mean that if you have an a minus b, regardless of what they are, and it's over b minus a, well, I can cross that whole thing out and replace it with a negative 1. In other words, when we got our final answer there, it was x minus 4 over x plus 5. Well, if it was x minus 4 over 4 minus x, then I can simplify that to minus 1. I wouldn't leave it as x minus 4 over 4 minus x.
Oh,
So
okay.
you always want to look for that. 90% of the time, you're going to be crossing out stuff that's identical, just like on this problem. I had a 5x minus 2 there and there. I had a 4x minus 1 there and there. I had an x minus 3 there and there. In other words, I didn't have that special exception that I was just telling you about. But that's not to say they won't give it to you in a problem. In other words, if I would have had and it doesn't work in reverse. It's got to be when they're only being subtracted.
Okay.
I mean, if I had a 5 plus x in the numerator, yeah, I could cancel those. They're the same thing, x plus 5 and 5 plus x. But what isn't always obvious is that that is just the negative of that. In other words, if you got a problem and you ended up with that, you might be inclined to leave it the same because they're not the same thing. So always look for a minus b divided by b minus a can be simplified to minus 1.
Okay.
Okay, that was quite a problem.
Yes.
I mean, only because it was the product of 3 things, and all of those things were quadratics. But we definitely got in some practice factoring into there. Now, we've got just a few minutes. Let's talk about logarithms briefly. I'm not going to talk about them a lot because we don't have enough time. But the most important thing you can know about logarithms is that if I have an exponential equation, which is what y equal b to the x is, and it's exponential because the variable is in the exponent. That is not an algebraic equation. That is an exponential equation. Well, all exponential equations have an equivalent logarithmic expression. And you only have to remember one thing to know what it is. And that is that logs are exponents. So I can write that much of it just by seeing y equal b to the x. Okay? Well, where's the b and the y go? Well, the b always goes down there. The only other place the y can go is there. So these two things are the same. If I were to take this exponential expression over here, 8 equals 2 cubed, which is true, and express it logarithmically, I would say what? The log of base what of what equals what?
The log of 2 and then
The log base 2
yeah.
of what?
Of 3.
No, remember logs are exponents.
Oh, of 8.
Yeah,
Okay.
the 3 has always got to go on the other side of the equation, leaving that for the 8. So these two things are the same also. And that's really the most important thing you can understand about logs is how to convert from one to the other. If I was given just this, well, the way I remember how to convert this back to exponential expression is to take the number on the far left, raise it to the power of the number on the far right, and it's equal to the number in the middle. In other words, 2 cubed equals 8. So if I have to express that exponentially, I can do it. And if I have to express that logarithmically, I can do it. And switching back and forth between the two is 90% of the problem when you're dealing with logs. You have to be able to switch back and forth between them.
Okay.
And that's,
Okay.
there's a bunch of other log rules that you need to memorize and stuff, but we don't really have time to get into that tonight. That's how my online sessions work. And I have recorded it. I'll stop the recording.